SS06, question 3 from the June 13 paper, a one-way analysis of variance. We're asked to look at the differences in braking strengths between low and medium and high level treatments for threads. You're told that the braking strengths are normally distributed with common variance, which is a necessary condition in order to do an analysis of variance. First question, carry out a one-way factor analysis of variance using the 5% level to investigate for a difference in the mean braking strength between the three treatments levels, low, medium and high. I would strongly suggest that before you do any calculations, you take out your tables booklet and just check what is required. Page 13, one-way ANOVA, you need SST and SSB, total sum of squares with that formula, and between groups sum of squares. Now, I've written the data out again. Given in rows, you know that you need the between group totals. So I'm doing the row totals, row 1, row 2, row 3. I've just done totals there. And you also need T, the total sum, which is 280, and the number of observations is 16. We also need the sum of each observation squared, which is 4,910.2. Please don't write outside the box. I shouldn't have done that. It should be inside the box for marking in the exam. Okay. Total sum of squares. From the formula, you need total sum of the x squareds. That's t squared over 16. In your calculator, that gives you 10.2 for SST. For the between group sum of squares, the sum of the totals for each group, here we've done the row totals, so that's going to be R1 squared over 5, R2 squared over 6, etc. And I've done that below. R1 squared over 5 plus R2 squared over 6 plus R3 squared over 5. Take away T squared over N, gives you 3.46. Now we have to enter those into the one-way ANOVA table. You have to learn the layout of the one-way ANOVA table. Top headings, sum of squares, degrees of freedom, mean squares, and the F ratio test statistic. On the left-hand side, between treatments, within treatments, and totals. Now, these values, SST and SSB, go in straight away. SSB, 3.46 is the top value. SST is the total value at the bottom. And the only reason we do the SST is because it's the quickest way to get the sum of squares within treatments. 10.2 subtract 3.46 gives you 6.74. Degrees of freedom. Between treatments, there are 3 treatment levels, which means that the degrees of freedom, 3 take 1 is 2. Total, there are 16 observations, 16 take 1 is 15. Yeah, again, we find the within treatments degrees of freedom by subtraction. 15 take 2 is 13. Now, to work out the mean squares, you do the division. 3.46 divided by 2 gives you 1.73. 6.74 divided by 13, 0.5184. To find your test statistic, your F ratio, you divide top value by the bottom value. Now I've got a test statistic 3.3367 or 3.34 to 3 significant figures. You'll find that in the mark scheme they allow quite a large range of values here, from I think 3.2 to 3.5, dependent on the degree of rounding that you've used in your calculations. So there is quite a large area here for rounding errors. Now, going back to the actual hypothesis test, you're required to test, going back to the question, for a difference in the mean breaking strength. So H0 is always no difference in the means. Now H1, you're testing to see if there is a difference in one or more of the breaking strengths. So the easiest way to write that down for the alternative hypothesis is to start with the words at least one. So my alternative hypothesis is at least one mean is different. We've got the test statistic. We now need the critical value. We use the F distribution in your tables booklet with degrees of freedom from between treatments, 2 followed by within treatments, which is 13. 5% level gives you a critical value of 3.806. Comparing that with your test statistic was 3.3367. I've written that as 3.34. Clearly, test statistic is not in the critical region. It's below the critical value. If it's not in the critical region, your conclusion is clearly that you accept H0. Must write that in context. Accepting H0 moving that into the screen. Your test statistic 3.34 is clearly not in the critical region. You accept H0. In context, there is no significant evidence of a difference in the mean breaking strength for the 3 treatments. Right, the second part of that question, 2 marker. What advice would you give the company about its choice of treatment level? As your conclusion was that there was no significant evidence, there is no advice that you can give on the basis of a difference in the mean breaking strengths. So I would suggest the following advice to get 2 marks. First of all, writing down that there is no significant difference observed in your test. So no recommendations should be given on that basis. However, you will get a mark if you suggest something along the lines. Advice would be for the company to choose the most economical, most convenient, or the cheapest. And that would be the second mark. Part B. If the distribution assumption made in order to carry out the test were found to be incorrect, state with a reason an alternative test that could be used. The assumption was that the breaking strengths were assumed to be normally distributed with a common variance. Normally distributed. If you don't know that the data comes from a normally distributed population, you have to use a distribution-free test, which you did in SS06, and the distribution-free test for the difference between 3 means is the Kruskal-Wallis. And that concludes question 3.